Hello, my name is Julian Nasario, and I'll be doing the Ansys Fluent project for the 2D CD nozzle on a conical nozzle for the midterm project. So first we'll start into design modeling. We'll do the XY plane, we'll start sketching, and then we'll just start making some lines. Each one is about each one is about just like pretty much its midpoint. Um, the dimension. This was to just build it up. The angle from the top part of the diverging nozzle is 15 degrees, the optimal divergence angle. Now that we're going to just delete all the unnecessary lines and dimensions. We'll go to concept, surface from sketches, in this quick sketch one, fly, we'll click generate, and there's our 2D wind tunnel with the dimensions. We'll close this. We'll go to mesh, let, let it open. So I'll start creating the name, uh, the name sections. I'll do like the name here, section. Well, done with that, we can insert or click mesh, insert method, select that line, go change the triangles, go right back up to the mesh one. Right, so well, first generate meshes are too small, too big. 0.03003. That's a little better. It'd be smaller. It would take too long to load the mesh. So that's good enough just for this video. Get on here, update, let it load. We'll open the set. Double position. And start. And we'll just let it open. Then like this open, click OK. Go down here to models, energy, equation, turn it on. Okay. Go to this viscous analysis, we'll click inviscid. Okay. We'll close this, we'll open materials, fluid, air. I'll change this to midterm air. And this ideal gas. We got a CP of about 1609.358. And then a molecular weight. You gotta be careful with the kilograms per kilomole. Usually it would be kilograms per mole, which would be 0.031, but now it's just 31 because of the kilomole. Create, change create, yes. Now that's done, close that. We can close this too. We open the boundary conditions, inlet, pressure inlet. And now usually this would be velocity inlet, but because we named this pressure inlet, well, that's what, because we have the pressure of the chamber. So we'll set the gauge pressure to 21 PPA. And then we'll just do just change thermal to 3400. My close was this. We'll open the outlet one. Same thing, we have pressure outlet. That's what we named it. It'll be zero gauge pressure, one multiplier, and we'll leave it about 300 at the exit. Close, we can close this, and the boundary condition. Go to initialization, initialize. Done. Go to run calculation. Set this to 100 iterations and just let it load. Calculation. We'll go down here to graphics, contours, and then we'll select all four surfaces. We'll start with velocity and save the display. This is relatively about right as the velocity goes through the throat, it'll increase as the expansion ratio increases, as the diverging area increases as we go down the nozzle. Next, we'll go to the pressure. It'll be pretty much the inverse of the velocity contour. As the velocity increases, the pressure decreases. Next, we'll move on to the density. It'll be around the same as the pressure. It'll look around the same as the velocity increases, the pressure, density, and temperature also increases. As you can see, next, we'll do temperature. About the same. It's about the same looking contour. Next, we'll go to the speed of sound, which is in properties. Change this to sound speed, save and display. About the same. It's a function of temperature, so it'll look around the same as the temperature. Next, we move on to Mach number. We'll go back to velocity. Mach number, save and display. It looks relatively similar to the velocity function as it is a function of velocity. And that'll be done for the contours. Next, we'll move on to the XY plot. So we've got plots, XY plot. We're going to have to create a new surface along the center of the wind tunnel. So we'll name this center, with points with the mouse to get a relative value. There, there. We'll change these to -3, 2, 1, 0.3, 2, 1, 9, this is 0. X is 0.078288 and 0. Great, it's the line, and then we have it right here. And so once we plot for each variable that we're looking for, you'll see on this. So first, just start with velocity. Say we plot along the center line, you can see as we go down the wind tunnel, not wind tunnel, the conical nozzle of the rocket, the velocity increases. Next, we'll move on to pressure. Say like what, it'll be like pretty much the inverse of the velocity function, as I said earlier. As velocity increases, the pressure, density, and temperature will decrease. So next we'll show the density. Looks relatively similar with different values. Next, move on to the temperature. Should also look similar. Temperature. Yep, but close enough. And then we'll move on to the speed of sound. Some properties, sound speed. They apply. We'll have the same, like I said earlier, function of temperature. So we'll go down as we go down the CD nozzle. And then last, we'll go to the Mach number. And being a function of velocity, it should look similar. There we go. I believe that is all that we are needing to show in this video. Thank you.